Hi, good day again to everybody. So, last meeting or in the last lecture I have discussed there some types of factoring. We were able to discuss the common monomial factor. So, in that, we inspect each term. If you can find a common monomial factor from each term, then you can just factor that out. And then the second one, we have the difference of two squares. And then after which we have discussed also the perfect square trinomial. So for today, I'll be discussing the next type, which is called the trial and error method. And basically, the process of factoring by trial and error method is used when the trinomial given is not a perfect square trinomial. So if it's not a perfect square trinomial, we now will introduce the method by trial and error. Let's get into some examples for you to be able to understand what I am saying here. So example number one. So let's say we have the trinomial a squared minus 2a minus 15. So if that's the trinomial given, if we will verify if this is a perfect square trinomial, well, the first term is a perfect square. So remember, for the perfect square trinomial, what are the things that you have to check? There must be two perfect square terms, and then the remaining term must be twice the product of the square roots of the two perfect squares. So here we have one perfect square. 2a is not a perfect square. 15 is not also a perfect square. So from the first criteria alone, that there must be two perfect squares, this trinomial is no longer a perfect square trinomial. Therefore, how do we now deal with a trinomial using the trial and error method? If there is only one variable, we will now look at the terms involving. So in this case, if you have exactly the pattern, uh, raised to 2, then followed by raised to 1, then followed by, practically this is raised to 0, because if this is a raised to 0, then that's just equal to 1. So if this is the order, normally we factor the one with the power of 2 and the constant. Of course, a squared will have no other factors but a and a. 15, we can have 15 and 1. We can have 5 and 3. Since we need a 2 as the term here, we can get the factors of 15 as 5 and 3. Therefore, if we will now factor this, what we do is we create two groups. We create two groups. Then we can place now the factors of a squared. One factor will go in the first group, the second factor will go to the second group, and then we will now pair each factor by the factors of 15. So we can place 5 here, and then we can place 3 in this second factor. Now, how about the signs? How do we now get the signs? So to get the signs, we have to verify in the trinomial given. So we have here a times a is a squared. Okay, so we have that. A times a is a squared. And then we get this as 5a. So we're just using distributive property of multiplication over addition. And this is now 3a. Since we need a minus 2a, this is positive. This is 5a, this is 3a. So to get a minus 2a, then this must be negative and this is positive because minus 5a plus 3a is negative 2a. So if this is now negative 5a, then since 5a comes from the product of 5 and a, then one of these must be negative. So we must place the negative here because earlier we have already seen a times a is already a squared. So minus 5 times a is minus 5a. 8 times this must be positive 3. Okay, to get positive 3a is, so minus 5a plus 3a is negative 2a. And then finally, we also need to check this minus 5 times positive 3. So minus 5 times positive 3 is minus 15. Wherein we have accounted all the terms. Therefore, the final answer will now be, so if you would just like to fix your final answer, actually the answer is already there. Let's just rewrite it. So final answer will be a minus 5 multiplied by a plus 3. That will now be our final answer. Next example. Next example is, let's say we have 2x squared minus 5x, and then let's say minus 7. That's 2x squared minus 5x minus 7. So you can inspect first, is this a perfect square trinomial? There must be two perfect squares. 2x squared is not a perfect square because 2 is not a perfect square. Though x squared is a perfect square, 2 is not. 5x is not a perfect square. 7 is also not a perfect square. So definitely, this is not a perfect square trinomial. Therefore, if we will now use trial and error method here, let's create two groups. And then, let's look at the original expression again. So in the original trinomial, we can find here that this is raised to 2, this is raised to 1, and then we have here x raised to 0. So it's already in that order. We have raised to 2, raised to 1, and then raised to 0. Therefore, we would like to look at the factors of 2x squared and 7. The one with the power of 2 and our constant. Of course, 2x squared, we have the factors 2x and x because 2 is prime. So we now place here 2x and x, or if you like, you can place x here, 2x on the other, or in the other group. That will not be a problem. And then 7 will be also factored. 7 is also prime. No other factors for 7 except 7 and 1. So where do we now place 1? Where do we place 7? Remember, this is called the trial and error method. That's why your first attempt is not necessarily correct, okay? So you have to try and try until you get the proper combination. So let's say we place here 1 and we place here 7 because 7 will have the factors 1 and 7. So if we place 1 here, 7 in the other group, let's check. 1 times x is x. 7x or 2x times 7 is 14x. So if we will add this, if both will be positive, then we get 15x. If one is negative, we get 13 as the numerical coefficient. But what we need to get is minus 5. Okay? So obviously, if we put 1 here and 7 in the other group, we will not get the desired remaining term. Therefore, if that's the case, so it means that this arrangement is incorrect. So what we can do is we can regroup our factors. So if you would like to retain 2x and x, then we can interchange 7 and 1. So if we will now interchange 7 and 1, let's try to get the remaining term. We have 7 times x is 7x. 2x times 1 is 2x. What we need is minus 5x. If we need minus 5x, this must be negative. This must be positive so that when we add it, we get minus 5x. So we get the remaining term minus 5x. So if this is minus 7x, so this must be negative. If this is positive 2x, then this must be positive. So let's double check all our terms. Let's use the distributive property again of multiplication over addition. 2x times x is 2x squared minus 7 times positive 1 minus 7 minus 7 times x is minus 7x. 2x times 1 is 2x minus 7x plus 2x is minus 5x. Remaining term also obtained. Therefore, our final answer is 2x minus 7. So I'm just rewriting our answer multiplied by x plus 1. Okay, so that will now be the final result. Another example. Let's have third example. Let's say we have 20y cubed, oh sorry, y squared multiplied by or r plus 23y plus 6. So question, is this a perfect square trinomial? 20 is not a perfect square, 23 is not a perfect square, 6 is also not a perfect square. So we don't have a perfect square trinomial. Check the exponents, raised to 2, raised to 1, and then raised to 0. So it's already arranged in that format. Thus, we want now to find the factors of 20y squared and 6. For 20y squared, of course, we can have 20 and 1. These are our choices, 20y times y. What else? We can also have 10 and 2 for 20. Or what else? We can also have, so we're just exhausting all the possible factors, 5y and 4y. On the other hand, for 6, we can have, if you like, 6 and 1. We can also have 3 and 2. So we're just listing down all the possible factors. So we need now to get the proper combination here. So you have different choices. You can have 20 and y paired with 6 and 1, or 20 and y paired with 3 and 2, or 10y 2y paired with 6 1 paired with 3 2, or 5y 4y paired with 6 1 or with 3 2. So we create two groups. So which do you think will be a good combination here? We need 23. Okay, maybe we can try 5y and 4y. Let's try this if it will work. We have 5y and 4y. And then we can pair this, let's say, with 3 and 2. So let's say we place 3 there, we place 2 there. Now will we check the remaining term? This will now be 12y. This will be 10y. Therefore, if we add this, if they will have the same signs, we get 22y. If they will have opposite signs, this will be either plus 2y or minus 2y. So it did not work. So if it did not work, it means we did not get the correct combination. Let's try to use another combination. So you can still stick, if you like, with the same pairs, but maybe we can interchange. So if you would like to retain your 5y here and have your 4y here, we can now put 2 in the first group and 3 will go to the second group. Let's try to check if we'll get the remaining term. This will now be 8y. This will now be 15y. So if we will add, what do we need? We need 23. Now, please also remember that if all your terms are positive, then all the signs in your factored form will be positive. Okay, let's check. We have 2y plus times 4y, is positive 8y. 5y times 3y is 15y. 8 plus 15 is 23. And that's the desired expression, 23y. And remaining, we have 5y times 4y is 20y squared. 2 times 3 is equal to 6. So all terms accounted for. So that will now tell us that we have the correct factors. So if we'll just rewrite it, therefore our final answer must be 5y plus 2 multiplied by 4y plus 3 as our final result. Another example. Let me give another example. So let's say we have the expression 6x squared minus 13xy minus 15y squared. Okay, so what made this example different from the previous examples that we have solved? So obviously in this example, we have two variables. We have the variable x and the variable y. So that's why we have x squared and then we have y squared, while the other one we have x raised to 1 times y raised to 1. Now, if your expression is something like this, of course, the initial solution would still be for you to check if this is a perfect square trinomial. Is this a perfect square trinomial? 6 is not a perfect square. 13 is not a perfect square. So definitely this is not a perfect square trinomial anymore. Now, we will be doing the factoring by trial and error. The hint here is we will now find the factors of the expressions having, in this case, the power of 2. So we will have to consider the factors of 6x squared and 15y squared. And then uh, this will now be the expression that we would like to come up with in the remaining element later on. So 6x squared, what are the possible factors? We can have 6x squared and, 6x and 6x and x, or you can also have, let's say, 3x and 2x, while for 15y squared, you can have 15y and y if you like, or what else? We can have, let's say, 5y and 3y. Do we still have other factors for 15? No more. Okay, so let's go back here. We create two groups. We now try to check the combination that we can use. Okay, so maybe we can try 3x and 2x for 6x squared. And then for 15y squared, what do we use? Maybe we can use 5y and 3y. Let's place 5y here. Let's place 3y here. Let's double check if we will be able to obtain the remaining term. This will be 10xy. This will be 9xy. So if we add this, if they have the same signs, we get 19. If they have opposite signs, this will be 1xy, either positive or negative, depending on where we place the plus or minus sign. But definitely, we don't get the 13 if we use this combination. Therefore, we try another combination. Okay. Uh, in this case, we don't just we it's not logical to just interchange 5y and 3y. 5y and 3y. So if I place 3y here and 5y here, what will tell us that this is not a proper combination? So let me just clear this out so that it will be clearer. So let me just erase this. Okay. And let me just rewrite it. So that must be 3y, 3y. Okay. So why am I telling that this is not a good combination? Because if you will observe, if we will use this, 3 becomes a common factor here. So if we find a common factor in one group, that will already tell us that that is not a good combination. Why? Because if that is a good combination, then it must be in the first place. We have already seen that in this case, 3 is a common factor for the original polynomial because if you will do this, you can factor out 3. So meaning you can factor out 3 also from the original polynomial. But since from the original polynomial, 3 is not a common factor, then it means this combination is not a good combination. Therefore, we now need to try another combination. Okay, so it means we have to change one pair there. So let's say we retain 3y and 5y and use 6x and x. Again, we cannot place 3y here because 3 becomes a common factor for 6x and 3y. So maybe I can place 5y here, then 3y goes here. Let's check if we get the remaining term. If we take the product of this, we get 5xy. If we get the product of this, we get 18xy. What do we need? 13. So that's possible. Negative 13. So to get negative 13, this must be negative. This must be positive. We get negative 13xy, which is the desired remaining term. So if this is minus 18, since it's the product of 6x and 3y, this must be negative. Then this is positive 5xy, so this must be positive. So let's check. 6x times x, 6x squared, check. 5y times negative 3y, negative 5y squared, check. 5xy minus 18xy, if we add, we get minus 13xy. All terms accounted for. Therefore, let me just rewrite our final answer. Our final answer is we have 6x plus 5y multiplied by x minus 3y. Okay, so just a quick recap. So basically, the trial and error method is applicable when our trinomial is not solvable by perfect square trinomial or the trinomial given is not a perfect square trinomial. So what do we do for a trinomial that is not a perfect square trinomial? So if we will use the trial and error method, we inspect which elements in the trinomial will be factored. Then we create two groups. Okay, then we find the proper combination such that when we expand those two binomials, it will yield the original polynomial. Okay, so there you have it for our lesson here, the trial and error. Again, from your module, you will find there some solved problems for uh, factoring by trial and error. I intentionally did not use those problems so that at least you can go over those problems again and review them. And then there are also problems in your module that you can still work on problems without solutions. Okay? So the next lecture video will be on factoring by grouping. So for today, I will now be ending this. So stay safe, everybody. God bless you all.